being recorded.
Sorry, it's
Oh, yeah,
recording
it's
now.
recording
Thank
now.
you.
Good
Thank you for
catch.
that.
Appreciate you.
Oh, anyone else want to answer the question by typing in the chat or anything at all? Yeah, Naman. So series resistors, you just add them up, and then parallel resistors are one over the reciprocal of each of the resistors. So just as a quick practice of that, what's the equivalent resistance of the circuit to the right over here?
Of all of the resistors together. So R1, R2, R3, and R4. What's the equivalent resistance of everything?
Yeah, go
Yeah.
for it.
Is it 8 ohms?
It's 8. Do you want to say like how you got there?
Okay, so I did 1/9 plus 1/9 plus 1/9, which is 0.33 repeating. And I did 1 over 0.33 repeating, which is 3. And that is all the parallel resistors added up. And then 3 plus 5 is 8.
Yeah, exactly. So we can simplify R2, 3, and 4, which are in parallel, to get a total of 3. And then we can add that with R1, which is 5, to get 8. Okay. And how many nodes are to the circuit in the right?
A lot of people
Mhm.
are guessing 4. Does one want to justify why they see 4 nodes?
Well, I'm looking at the dark blue dots. That's why. I don't know.
Yes. That's a good I'm glad you had that misconception. That was kind of the point of me putting that there. The dark blue spots are not nodes, so I'll let Rita keep talking, but that's what the next bit of the lesson is.
Yeah. So we're just going to go over what nodes are because I think a lot of people were kind of confused on it. So however you like draw things in a circuit, it doesn't really matter. All it matters is like how they actually connect. Like if I drew like a really long and weirdly shaped wire to connect like two components, I could just draw like a regular one. It doesn't matter like how they're actually drawn, only if they're connected. So a node is defined as a wire connecting two or more elements. Oh, how many nodes do you see in the below circuits? Two, yeah. Because there's a node connecting them like on the bottom and one on the top. So what about this circuit? Does anyone want to explain where they got four or whatever their answer was? Yeah, Savika?
I got 4 because, like, in the explanation you gave, that where the node is when it connects two or more circuit elements, and then in that example it was given 2. I just saw that the voltage and then the resistance pattern, like, there were 2 in the left and then another 2 on the right.
hmm That's a good like thought process, but we're kind of just talking about like the wire that connects them. So there's a big wire connecting the voltage and then both resistors, and then there's another one connecting them here. But like it doesn't really have something to do like with the dots technically.
Yeah,
Wait,
So
Naman, do
try,
you have a question?
no.
so how about the battery side and the one which says R2? Would those also not count?
So remember, nodes are just connections between elements, okay? When we talk about nodes, what we're really talking about is a place where voltage, like the actual literal voltage is the same. And anywhere that's connected by just wire will have the same voltage. So on the circuit on the far left, it's pretty easy, right? We only see a battery and a resistor, so there's only two connections between things. There's only two nodes.
You
For
don't
the
have to
circuit
connect
in
it.
the what for the
Yeah,
circuit in
yeah.
the yeah. So for the circuit in the middle, there's two wires that connect things. There's two points of connection between elements. R1 and R2 are connected to the same node that V1 is connected to, right?
Okay.
Yeah, Jay?
Yes, I get it. Thank you.
Is it 3?
Oh, what?
The one on the right.
Like the middle one.
Did you get three?
What?
How did you like come to the conclusion of
Oh,
three
because I
nodes?
thought like from the V1 it would go like up top and then it would stop at the blue square. And then after that, another node would be from the blue square going to the right to the other blue square, and then from the blue square to the back to the beginning.
Hmm. So with voltage, like the voltage going from all the way over here, going down here, is the same amount of voltage that would go all the way over here and go here. It's not like the voltage splits in half at the node, because like the
Okay.
potential difference across it is the same, if that makes sense.
Echo. Thank you.
It's
Yeah.
important when we talk about nodes, we're talking about node voltages. The current going in and current leaving a node is how we'll actually do nodal analysis, but a node is defined by its voltage, not by the current going in or current going out. So keep that in mind.
Hmm. Does everyone want to try the right one? Does anyone want to explain how they got one? Oh, let's not spam in the chat, please. Does anyone want to explain their like thought process?
Is it because voltage one and resistor one connects together? That's like the one node.
Yeah, there is one node here, but there's more than one.
Oh, so would there be three? One connecting from voltage one to resistor three to resistor one, and then resistor one to voltage one?
Yeah, exactly. So we
Okay.
have one over here, one over here, and one over here, because the voltage is different at each of these 3 points. Does anyone have any questions, or does that make sense?
So in a parallel circuit, it won't go at every point, every turn. So like we didn't put a separate node kind of at resistor one and resistor two for the middle. But here it's a series circuit, and because it's a series circuit, it will have different voltage. So that's why we have multiple nodes, if I'm correct.
Yeah, that's
Okay.
exactly correct.
I just want to quickly note that when you're thinking of nodes, some of you guys are thinking of the drawing itself, but a much better or the correct way to think about it is you guys where voltages are not the same. So if in this case, when you're looking at the second example, even though it branches to R1 and then R2, there's not separate nodes there because the top bit of wire counts as your node. The voltage doesn't change as it goes from R1 to R2 since it's in parallel. And if you're confused on why that's the case, just like message me in private chat so we can continue. But don't think just because it branches or turns that there's a new nodes that are being created. You have to look at where they have to specifically look at voltage when you're doing that.
Yeah. Okay, so finding voltages at some nodes are pretty easy. Like the ground, we always know that the ground is 0 volts. And then if we don't care about certain nodes, we can combine resistors to simplify the number of nodes we need to solve for. So over here we have 3 nodes, but if you were to simplify it into one resistor instead of two by adding them up, you would only have 2 nodes and you'd have to solve less equations. But in general, we need more than that because simplifying resistors isn't enough to solve like every circuit ever. The goal is to write the currents going in and into and out of every node in terms of voltages of each node, and that's nodal analysis, which is what we went over. And then we just have to solve the system of equations. So, quick example, find the total power supplied to the circuit below. Okay. So this means we need to figure out the current going through all the batteries, right? So we can multiply it by the voltages to get the total power. And we can do this with nodal. So yeah, where are all the nodes?
Just someone like unmute and point out where the nodes are. So let's speak.
So I see one node from V1 to R1, and then another one from R1 to R2, and then the third one's from R2 to V3, and then from V3 back to V1.
Hmm. Yeah, exactly. Because those are where all the voltage differences are. And we already know the ground node is 0 volts. We also know that the voltage difference, we also know the voltage difference across the batteries without even thinking about it because we have the voltages right here, right? So if we have all the voltages, then we can easily find the current going through.
And someone before we show it, are we clear on why the voltage at those top three nodes at the left, middle, and right corners are 5 volts, 10 volts, and 15 volts? Is anyone unclear on that? If anyone is unclear on that and they're not speaking up,
Yeah,
it's
just a private
because
message, one of
at the
us.
bottom,
Oh yeah.
at the bottom, we're at ground. And so as we go, I guess you can't see my cursor right now, but we're at ground. And as we go through one of the batteries, we just gain whatever the value of that battery's voltage is. It's the same way when we go across a resistor, we drop voltage. When we go through a battery in the direction from negative to positive through the battery, we gain voltage. For the battery on the left, we gain 5 volts. The middle, 10 volts. The right, 15 volts. And since below those batteries, we're at 0 volts, ground. When we go above them, we're at 5, 10, or 15 respectively. Are we A-okay? Okay.
Okay. Can anyone try calculating the current going through R1 since we know the voltages at the nodes? Neil, yeah?
Is it half an amp?
And how'd you get there?
And in what
Um,
direction is it?
it's
Yeah.
from the 10 volt to the 5 volt.
How'd you get there? Like, how'd you get to half?
Oh, so like I use the equation, like the voltage equals IR, and then I found the current.
Okay. Does everyone like
Uh,
understand that vaguely or any questions?
how did you know what to use for V in V equals IR?
I just minused it.
Minus which ones?
10 and 5.
Yeah, because so you did it without thinking, because for you it's second nature, right? Because you've gotten a hang of these things. But for anyone who hasn't gotten a hang of it yet, remember we care about the voltage drop across the resistor. V equals IR says the voltage that a resistor drops is equal to the current through that resistor times the value of that resistor. So we don't do 10 minus 0 because the resistor is not connected to 10 and 0. The resistor is connected to 10 and 5. So 10 minus 5 is 5. And it's going to the left because current goes from high voltage to low voltage, high potential to low potential. Okay. But yeah, that was all correct, Neil.
Okay, let's try the current going through resistor 2. Yeah, it's 1 6 amps. Does anyone want to unmute and say how they got there? Savika?
I got there because first I minus 15 and 10, so then I'm given 5 volts. And then since there's the equation to find the current, which is I is equal to V divided by R, 5 volts divided by 30 ohms is 1/6 amps.
And which direction would it go?
It would go to the right. Or
Remember, voltage goes from high to low potential. So from
wait,
like,
then
yeah. So from the bigger number to the lower number. So it would go towards the left.
Okay.
Yeah. Okay. So we have 1/2 amps over there and then 1/6 amps. And then we can use Kirchhoff's current law for the current through the 10-volt battery. Does anyone know how to get the current through it? Or like unmute and explain? So remember, Kirchhoff's current law is essentially at this point over here, all the currents going in and out has to equal 0. Yeah, Evan, 1/2 minus 1/6, so 1/3. Does everyone understand that? Because we have 1/6 going in and 1/2 going out. No questions? Okay. And then after we have all the currents, we can just use P equals IV to add up all the contributions from the batteries. But the current's entering the wrong side of the 5-volt battery, right? Because it's going off.
Okay, I was gonna answer like the what does this mean for power like question.
Yeah, go for it.
Oh, you subtract it.
So the 5-volt battery absorbs the power. It doesn't supply it like the other two. So then we just like calculate it at each of the nodes, right? Savika? Yeah.
Why does the 5-volt battery absorb the power?
Because the current's going in through the positive side and out the negative side, which is like opposite of what the right way would be.
All right.
So if you've done any chemistry, I don't know how many people here have chemistry experience, but if anyone has done chemistry, you'll know that batteries, they're called electrochemical cells. They basically have some miraculous substance in one cell and some miraculous substance in another cell, and through more miracle science, that encourages a potential difference between those cells, right? Anode and cathode, yes, those are the technical terms for what these are. But it's against what is the word is thermodynamically favorable. It's against what the universe wants to happen for current to flow in the wrong direction through that cells. Okay. And so that means the battery is absorbing power instead of supplying it like it normally would.
Yeah.
Batteries are not like they're really annoying circuit elements to me actually because they're just chemical things. And so we just model them as things that give a voltage gain. But the actual internal workings of a battery are not electrical things, they're actually chemical things. So yeah.
Mhm.
Sorry.
Yeah. In this case, you can just think that you're supplying the battery with like extra charge for later. Like it's not affecting the circuit as in like it's like in a way where it's like, oh, it's like giving voltage anymore. It's like you're charging it. That's an idea.
Yeah. And then we use P equals IV to find the power at each of the nodes. And then all the equations are on the side, and it's just like math. So 1/2 current times 5 volts, we have 1/3 times 10, and then we have 1/6 times 15, and then we get these values which we add together. Does anyone have any questions about like just the math portion of that? We all good? And it'd be 1/6 times 10.
Why do you say 1/6 times 10? What's the what's your reasoning? It's okay. I mean, it just should. What? Oh my goodness. So yeah, it wouldn't be 1/6 times 10. Remember, all we're doing is current times voltage for each of the batteries, right? So for the 10-volt battery, we have 1/3 amps going in the right direction. 1/3 times 10 is 3.33. For the 15-volt battery, we have 1/6 amps going in the right direction. So 1/6 times 15 is 2.5. And for the 5-volt battery, we have 1/2 amp going in the wrong direction. So 1/2 times 5 is negative 2.5. Okay, and we just add up all those powers to get the total power supplied to the circuit. Is that clear? Yeah. Okay.
Okay.
So the reason that you'll notice in this example, we didn't even have a system of equations or anything, right? I mean, we already knew all the node voltages, and all we did was Ohm's law. And I did that on purpose because it illustrates the power of nodal analysis. We don't need to, often we can simplify the circuit. There's a lot of neat tricks we can play, especially with where we place ground, that make our life easier. If we instead put ground where the 10-volt node is, our life would be harder. We would have more things to solve, right? And so and you'll see actually in one of the solutions to the challenge problems, a lot of the most important tricks we play in circuits are just by being creative with what we do at the beginning, and then the math works itself out. Okay? So, yeah, nodal analysis is very, very powerful, and it's really the only circuit analysis technique I use. We'll talk about mesh, but honestly, nodal is just, it works always.
Yeah. So now we're gonna do a Kahoot to practice. Oh, it's private. Ishaan, you can.
Wait, why is it right? It should be on the, okay, I don't know why it's private, but I guess I can. Am I going to be able to? Okay.
Didn't you make it?
Yeah, but I made it on the ScioCamp. Oh my God, bruh. 1 second. Let me log in.
A little bit of technical difficulties. If any of y'all have like questions while we're doing this, just like type in the chat.
Stupid. Kahoot Premium. I remember back in my day, there was no such thing as Kahoot Premium. But then corporate America struck again.
Really showing your age there. That was like 8 years ago.
That was when I was in middle school. I'm not that old.
Okay. Close to 8 years.
Okay. That's hacking into the mainframe. 1 second. Okay, I'm in the mainframe. Sharing screen. Okay, go ahead and join. So what this is basically another nodal analysis problem, but each step is a Kahoot question. Okay, that's all it is. So am I from ancient Mesopotamia? Yeah, roughly. In other words, 2005. Like, what's crazy is there's some people born in this class in the 2010s. That just makes me sad. Like,
Where did they send the link?
I think the majority of them did.
on the screen share, you should be able to press the game pin. I'll type it here as well.
2012? Dude. No way.
Yeah, you can name yourself whatever you want.
Yeah, this is just for practice.
If you keep it appropriate, I guess.
Yeah, try and get us not kicked out of ScioCamp. Appreciate that.
Why did Kahoot add profile photos? It's a good question.
Yeah, we can join.
Oh. Did they hit the cap?
It said like Kahoot stopped working because of an unexpected error.
Oh,
That might
reload the
be
page. You know how to do that.
for you. I guess we can make it for points. Sure. Yeah, this is for points.
Yeah.
It's also for your educational enrichment.
Yes.
And since we're making it for points, Toby, I would prefer if you did not compete. I think I just kicked someone out on accident. Sorry if I did that.
What the heck?
Toby, since it's for points, I would prefer if you didn't compete in it.
Oh.
I can't join. It still says something went wrong.
Can you try like Microsoft Edge or a different browser or something?
Oh, okay.
Yes, you will see the questions. There's just the questions right now. Kahoot.it. Yeah, go to Kahoot.it. That's a good point, Beatrice. I'm just gonna on full screen. Should be fine.
Okay, I got it.
Okay, are we all good? Anyone have any concerns before we start? You have 5 seconds or forever hold your peace. Okay, here we go. Oh, I don't remember how much time I gave for each question. I might not have. Okay, well, we'll see. Some
Yeah.
of
20 seconds is kind of fried, dude.
some
Can
of
you
these
turn on the
questions.
music?
Turn on the music or turn off the music?
Turn on. I can't hear.
The music is on.
You have to share audio.
I'm jamming to it right now. I guess I'm jamming alone.
Heck yeah.
Oh. Let me share sound. Okay, so yeah, 27. That's pretty good. Just to be clear, remember, can you guys see my cursor right now? Oh,
Yeah.
can you see my
Yeah.
cursor? There's one node right there at the left, one node in the middle, one node on the right, and one at the bottom. Wherever two elements or more are connected but only by wire is a node. Okay, so that one's pretty simple.
Nice job, guys.
Some of these are going to be harder to do in 20 seconds, but you'll see my chopped drawing of it's delayed. Yeah, I don't know what to do about that. I'm sorry. Okay, so yeah, 0 volts. Because remember, node D is ground. Just like that. Snap at 0 volts. Should be that quick.
Yeah. I think you might
We'll
want to
give-
stop sharing audio because then it's causing it to lag.
Okay. Sorry guys, no Kahoot music for you.
I can play like really low quality Kahoot music into my microphone if that makes you feel better.
That is not right. Okay. I think I just lied.
Yeah. It is 5 volts, guys. You got it right.
It is indeed 5 volts. So someone was rewarded for saying
Someone
0
logged
volts.
in.
We'll see who it was. I think I know who it was. That's my bad, guys. I haven't made a Kahoot in years, I'm not gonna lie. So in terms of the voltage in that middle node, what's the voltage at the right node? Okay? Careful about the wording here. This one also is very doable in 20 seconds, even if it seems hard. 2 seconds, answer. Yeah, so some people got it, but it's harder. So remember, if the voltage at VB, let me annotate. So the voltage at VB, this guy right here, that's VB, okay? VB. And as we go across this battery in this direction, we gain 20 volts, okay? So we're going in the other direction, so we lose 20 volts. Remember, when you go from negative to positive along a battery, that's where you gain voltage. And so since we lose 20 volts going from B to C, it's going to be VB minus 20. Does everyone understand that? more so than the Kahoot points for understanding how to use this very important technique. Do you understand what I'm saying here with this being VB
Wait, can
minus
you
5?
explain it again?
Yes, yes, yes. Okay. So this node right here, we've defined this with the variable VB. Okay. In general, for example, how we got this voltage right here, which I lied about the answer for. When we go from 0 volts below the battery up through negative to positive along the battery, we gain plus 5 volts because that's the value of the battery. That's just what the battery like does. Okay. As we go from negative to positive along the battery, we gain 20 volts. Okay. But I asked you for the voltage at node C in terms of node B. Node C is in the other direction. So it's this voltage minus 20, okay, because we're going in the other direction. Oh, the battery. Is that good?
Yeah, kind of.
Okay. I think a simpler explanation is that the question is really asking what's the voltage difference between the 2 points, C and B, and then you just have to add that VB term in to make it like in terms of it, if that makes somewhat sense. So all you're trying to actually find is the like numerical voltage difference between C and B. And since you're going from the positive to the negative end of the battery, instead of adding 20 volts, you're subtracting 20 volts.
Okay. Yeah.
So yeah, not VB plus 5 would be that this it's a 20-volt battery. And it's not plus 20 because it's in the other direction. So just be careful. Can we I don't know what's going on in chat, I don't care. Oh, I skipped the scoreboard. My bad.
It's been lagging, so we can't see the scoreboard anyway.
Okay. This is a really vague question.
This question's kind of bad, dude.
Yeah. Yeah. Okay. So, the next step cannot be simple. How would you simplify this resistor network? Right. For someone who said simplify the resistor network, what is your proposed method of simplifying the resistor network? I know it's scary, but no one wants to speak up. But the answer is you can't, right? First of all, we have to find parallel or series combinations. These resistors are not in series, okay? It's not one current that goes through both of them. That current splits. There's also current that goes there. And these resistors are not in parallel. These guys are not in parallel because they have a different voltage drop across them. This resistor has a VB minus 20 voltage drop. This resistor has a VB voltage drop. So there's no series of parallel resistors even present here. We can't simplify these resistors at all. We have to resort to nodal analysis. Okay. And so if you're guessing getting it right, remember the point of this is to teach you circuits. I know Kahoots are fun and all, but like learn the circuits. Okay. This one's also a little tough, but 20 seconds is enough. Okay. Yeah, great. So a lot of people got that one. For anyone who said 15 times VB minus 5, remember Ohm's law is V equals IR, right? Oopsies. It's V, okay, V equals IR, okay? And if we're interested in I, then I equals V over R, okay? But yeah, most people got this. That's good. Okay. So let's just go ahead, go to the next one. Evan K is in the lead. So this drawing is like super scuffed, but the blue arrow's in the middle. It's going along the 5 ohm resistor. Yeah, so a lot of people got that. Some people didn't answer, I think, because they were still thinking. And in general, I don't like Kahoots because they force you to not think and act fast. But like, remember, we want the voltage drop across this resistor. At the top, it's VB. At the bottom, it's 0. VB minus 0, and then divided by 5. Okay? That's all it is. Because we divide by 5 because that's the resistance V over R equals current. I can't extend the time right now because, I mean, can I?
I think you can. No. Oh,
Whatever.
what no.
Yeah.
Next one, we'll make sure to do it. And I think we're also going to remove the time elements as well.
Okay, so this one was tougher. Remember, I think this one I intentionally drew to be a little challenging, okay? So remember this current, that purple arrow, that current is the same as this current, okay? And this current is just that voltage drop divided by the resistance. That voltage drop is equal to VB minus 20. I'm not going to rewrite it. VB minus 20 at the top, 0 at the bottom. So the voltage drop is just VB minus 20 itself. And the resistance is 10. So VB minus 20 over 10. So don't search up the answer. I don't know why you would do that. But yeah.
How would you
So
get the answer if you search it up?
So does that make sense? It's just the voltage drop. And the current here, I drew it there, but it's the same as this current here. Okay? It's just one line of wire. You good? Yeah. Again, we'll have some actual problems where you can take your time soon. So I wouldn't stress too much if you're not getting it so fast. This one, well, no, this one, 20 seconds is fine. She's also quick.
How did you get some like LaTeX font?
It's built in.
Really?
Yeah. So, okay. Let's take note of what's going on here. No current goes in. So that's the 0. The 0 is because no current goes in. The rest of these terms are the currents going out. What goes in equals what goes out. This term goes out, this term goes out, and this term goes out. So we just add those together. Okay? I know it feels weird to set all those equal to 0, but remember some of these could be negative. We could find that this term, for example, is negative. In fact, we will find that this term is negative. And that means the current is just in reality going in that direction. But that's completely fine. There's nothing wrong with that. It's just we get a negative number. All is good in the world. Good questions. Okay. Okay, last one. Shouldn't need a calculator for this. Boom, 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 boom. Sorry. Yeah, that was hard. So I know it seems so I was intentionally messing with a lot of you guys. Notice the direction I drew this arrow. I drew it going up. Okay? A lot of you said 1.27. That's the current going in this direction. And this is the point I'm trying to make. When we do nodal analysis, we need to take note of where we have set the direction of our current arrows, because that will impact the answers that we get. So a lot of you said 1.27, that's the current in the orange arrow, but I said the brown arrow, which is going up, so it's negative 1.27. Okay, it's a stupid trick. In reality, you would never care about that. What you would care about is this direction. But yeah. So that's that.
Now for the leaderboard, which I don't think we've seen before.
Good job, Aiden. Good job, Aryan. Good job, Evan,
Nice.
Chris, and Alpha. Whoever Alpha is. So we'll just someone take note of that. Okay, so now let's get back to actual content. And let's lock back in, please. So we're just not gonna I don't want to cover mesh today. I mean we can just do this example. And we're not gonna get to mesh, and that's fine. I'd rather spend more time on those. So we have another example with Nodal here. Okay. So what I want to do, I'll give you guys, say, a couple minutes to try this yourself. Okay. So go ahead and solve for the current going up through the 12 ohm resistor. So when I say up, I mean that direction. Solve for that current right there. Okay. And you're going to want to use nodal analysis here. There are indeed 3 nodes, right? But I want you to solve the whole problem. We're not going to go step by step on this one. Well, we will. I'll show step by step. But first, I'll give you guys a couple minutes to solve it yourself. Okay. And we're not going to do much more practice with nodal analysis in class, but there will be so much practice on the problem set, which will be released later tonight, probably, for you guys to do tomorrow and the day after. Okay. And if you really want to be good at circuits, you should do just all those problems. Okay. It'll take a bit of time. We'll get a lot out of it. I promise. So if anyone is struggling of where to start, take note of what we always do when we start nodal analysis, which is figure out which nodes you need to solve the voltage of, okay? Which may or may not be the things I've circled in purple. Okay. And also take note of the fact that we only care about this current. So maybe there's something I can do with these 2 resistors that'll make my analysis even easier. In fact, maybe there's something I can do with these 2 resistors that'll make my life even easier to find the node voltage. In fact, maybe there's some Kirchhoff's current law I can do because I know that whatever current flows down through the source through here has to be the same as the current that flows up through here. Just maybe. So don't say your, oh, it's too late, but don't say your answer in chat, everyone. Just we'll give like a minute or 2 for people to solve it, for people to solve it. If you want to DM me the answer though, I'll let you know if you got it right. No one has gotten it right yet, fortunately. A lot of people are guessing 2 currents. I'm curious as to why. But let's go ahead and go through it now. So, first of all, we know this current source has 6 amps going through it. 6 amps, okay? So that means there's 6 amps flowing through here, okay? That means the sum of this current and this current is 6 amps, okay? So I'll call this guy I1. I'll call this guy I2. I1 plus I2 equals 6. Are we good on that? Does everyone agree with me that I1 plus I2 equals 6? Is anyone doubtful that I1 plus I2 equals 6? So Let's call it that. So let me start with the more brute force approach, where we literally do go through and find all the node voltages. Okay, so let's call this voltage right here VA. Let's call this voltage right here VB. And this whole node right here is going to be 0 volts. Okay, that's 0 volts right there. First of all, we can replace R3 and R4. We can simplify that parallel combination and replace them the single 2 ohm resistor. Okay, that's the parallel rule, right? The 4 ohm resistors are in parallel, and we can simplify them into a single 2 ohm resistor. Okay, so now we know VB over 2 is the current going down here. I'll use a different color for that. VB over 2 is this current right here. That's VB over 2. But there's only 6 amps going into that node right there. So actually, 6 equals VB over 2, right? There's 6 amps of current going in, and that's the only place those 6 amps can go, is down that resistor. Okay? I'll give the intense code in a second. So that means VB is 12 volts. Okay? So if VB is 12 volts and there's 6 amps going down here, we also know there's 6 amps going up here. Okay? And so VA over what? What is the parallel combination of these two resistors? Someone tell me in chat. 4. 1/12. Yeah, it's 1 over 12 plus 1 over 6. And if you do the math, that comes out to 4. So VA over 4 equals 6. So VA equals 24 volts. So now we know the voltage right here is 24 volts. And that means the current down here is 24 above minus 0 below over 12, which is equal to 2 amps. I'm going a little fast, I know. But if that's confusing to you, you need to work through these problems yourself. Us explaining to you how to do problems is not going to get you very far. You need to do practice problems. That is the best way to learn, without a doubt. So we're not going to do the nodal analysis, or the mesh analysis, but maybe next time we'll talk about that. Here's the attendance code. Make sure to fill out the feedback form for midpoint feedback as well. Please be honest. We'd love nice feedback, but what's also important is how we can improve, how we can be better teachers for you. So all feedback is appreciated. It's completely anonymous, and we want to give you guys the best possible learning experience. So whatever you want to say, please feel free to say, and we will not be offended. That's it for attendance. And then the form below is for midpoint feedback. And are you sure about that? Yes. The fact that you're saying that makes me worried that you're going to say some really mean things, but it is anonymous, and if you have mean things to say, then you can say them respectfully, and we will work on it.
We have like a little over half of our classes left. We want to make sure that it's good. If you guys want us to improve it, or if you guys think it's already good, then let us know so we don't change things that unnecessarily don't need to be changed.
Yeah, and actually, for those of you who are still listening and aren't completely zoned out, the other trick for solving this circuit is noticing a resistor it just resists current, right? And so if I have a total resistance, I'm not simplifying the resistors, I'm just adding up the shares of resistance of these guys to 18 ohms, okay? And so 12/18 of that is resisted by this resistor right there. So this guy's resisting 12/18. The other resistor is resisting 6/18. Whatever the resistor doesn't resist is the current that's going to go through it, okay? So this resistor right here is going to take 1/3 of the current. 1/3 of whatever current's going into here is going to go through the 12 ohm. Sorry, 1/3 of the current that's going into here is not going to go through the 6 ohm resistor, and 2/3 of that current is not going to go through the 12 ohm resistor. So then we can just solve it immediately. We know 1/3 of the current does go through the 12 ohm resistor, so that's going to be 1/3 times 6, which equals 2. And we know that 2/3 of the current is going to go through the 6 ohm resistor. 2/3 times 6 is 4. And that's our problem done. That was really quick, so that probably did not make much sense. But you can think about circuits entirely logically like that. Yeah, it's okay if you resubmit it with the correct attendance code. Yeah. Bye, peoples. I was just talking to fill in the time, but Ampere 4 is the attendance code. Can I explain that again? Yes, of course. So think of resistors. The value of a resistor tells you, this is going to sound like an incredible concept, but the value of a resistor tells you how much it resists current. Okay? So if I have two resistors here, I have one resistor that is 12 and one resistor that is 6. Okay? You can literally think of it like there's 18 apples. Okay? The 12 ohm resistor is going to say, no, I don't want 12 ohms. No, I don't want 12 apples. Okay, that's what its resistance means. The 6 ohm resistor is going to say the same thing, but for 6 apples. Okay? And there's 18 total apples to be handed out. What I mean by apples is the amount of current going into here. You can think of it being divided into 18 bits. Okay? So the 12 ohm resistor is not going to take 12 of those apples, but there's 6 apples that it will take. So 6 out of 18 goes there. The 6 ohm resistor is not going to take 6 of those apples, but it will take the other 12. So 12 out of 18 goes there. Okay? And the total current going in is 6 amps. So 6 out of 18 times 6 is 2. 12 out of 18 times 6 is 4. Okay, it's just a little trick that you can play just by thinking through it with only logic to solve it. Is there any YouTube channel you should look at if you're lacking? There's tons of stuff out there. Khan Academy has great videos on it. There's also just so many things on YouTube
Yeah.
to look at.
I loved OrgoChem Tutor because you guys have been taught already the basic fundamental understanding, like what is a resistor, what's a battery, what is a current voltage source. So you can jump right into those videos and do guided practice problems.
Yeah.
That's how
And
I
if-
ended up learning a lot of this stuff. So I think if you guys like the more lecture style, you can try that.